verify that h of x equals 1 over x on the closed interval from 1 to 3 satisfies the mean value theorem, and find all numbers c that satisfy its conclusion. Now, this function is continuous everywhere except when x equals 0. There's a discontinuity there. So we need to make sure that our interval does not include 0, but it doesn't, so we're good to go. Also, the derivative of 1 over x is equal to negative 1 over x squared, right? Because this is the same as x to the negative first, and when we differentiate, that's negative 1 x to the negative second. So same as negative 1 over x squared. And this is also defined everywhere except 0. So we are good to go for the mean value theorem. We need to find all numbers c that satisfy h prime of c equals our function at 3, so it's going to be 1 over 3, minus our function at 1 over 1, all over 3 minus 1. Now, 1/3 minus 1 is going to be negative 2/3, and this is all going to be over 2. And negative 2/3 divided by 2 is negative 1/3. So we need to find a place where our derivative is equal to negative 1/3. Now, the derivative at c is going to be negative 1 over c squared, and we need that to be negative 1/3. Now, clearly these fractions are going to be equal if the denominators are equal. So they're going to be equal when c squared equals 3. We can also get this by multiplying both of them by negative 1 and taking the reciprocals of both sides. And so this is going to give us c equals the square root of 3. We don't need to consider the negative square root of 3 because our interval only includes positive numbers. And the square root of 3 is approximately equal to 1.732, which is in our interval. So that is the value of c.